The snow lab?
I have actually. I got to go back in, it was like, it must have been like 2010, 2011, really early on. They were missing an experiment in the cryo room. So it was a giant, empty, clean room. There was nothing there yet. YouTube is ready to go. Yeah, have you been to Snow Lab, Chris?
Yes.
Oh.
I forget the year, but it was probably 5 years ago, 6 years ago.
It's so cool. For those of you who are joining, we have 112 people with us right now. Hello, everybody.
Hi.
So Snow Lab is a particle physics lab in Sudbury, Ontario. So it's about 4 hours north of Toronto, and it's built in an old mine. So it goes down 2 kilometers, and then it goes through the mine about 2 kilometers, and then you get to the end of it, and there's essentially a giant clean room. There can't be any dust in it, and you have to completely change and shower and get all the dust off, and then put on new clean clothes and hats. Yep. And like the little caps over your hair and all that. And then there's all these experiments down there about neutrinos and dark matter and stuff like that. It's really, really cool.
Yes, Snow Lab stands for the Sudbury Neutrino Observatory. It's in the Creighton mine.
And if anybody...
It's in a working mine still.
Yeah, that's the cool thing. When you go down with all the miners, eh?
Yeah.
And if you heard about I believe it was 2015, Art McDonald won the Nobel Prize.
So when I went on my tour, he was our tour guide.
Oh, that's so cool.
Yeah.
Oh.
He hadn't won yet.
Oh, that's so cool.
Yeah, just this humble guy. Hi, my name's Arthur.
Oh, so cool. And then went on to get the Nobel Prize. So cool. So we do some really cool stuff for those who don't know about neutrinos. They really don't have too much to do with observational astronomy, but they're really, really cool. They're these little tiny, almost unnoticeable particles. They're neutral, which is the name neutral, or neut of neutrino comes from the fact that it's neutral. And eno meaning very small. They're almost massless, and they have no charge. And so they're really, really, really hard to detect. And the way that we detect this type of neutrino, which is their solar neutrinos coming from the sun, is you go down into under a whole bunch of Earth to weed out anything that's coming from the surface. And you wait for neutrinos to bounce off the nuclei of heavy water, of deuterium. That's what they do they look for little tiny flashes of light to find them. Yep. Absolutely amazing. So cool. So those of you who are just joining us now, I'm going to start a poll because we talked about this last time, just to see what you guys think of your favorite constellations. I can't list them all, and you can't write everything in, unfortunately, but of the ones that we have listed there, tell us what your favorite is. Oh, and while we're waiting too, Chris, because we still have, I guess it's actually 3:31 technically. We'll give people an extra minute or two to join.
Sure.
Can you answer a question from last time that I forgot to mention?
Sure.
So that question came from somebody in the chat. They said, is it true that if you lowered yourself down a deep well, you could see the night sky in the middle of the day?
No, unfortunately, that's not true. You still have the Earth's atmosphere over top of you, between you and space, and all that sunlight gets scattered through the atoms of the Earth's atmosphere and creates that bright patch of sky. So.
Oh well.
But if you built a tower high enough, you could climb up above the atmosphere, and then you'd see the sky. Then you'd see the stars.
Pretty cool. And now I have a follow-up question, because during total solar eclipses, can you see the stars then?
Can you see the stars then?
Mm-hmm.
You can see the brightest ones. Depending on the eclipse, the sky will get reasonably dark for 2 minutes or so. And you can certainly see the planets, and you can see the more prominent stars without any problem with the unaided eye.
That's pretty cool.
With binoculars or a telescope, in theory, you could see many, many more stars during an eclipse if you knew where to point, knew where to look for them.
Okay.
Mm-hmm.
That's really cool. So I guess it's just because there's less sunlight in the atmosphere then, eh?
Yeah, the sky is darker. Once the sky is dark, then the dimmer objects appear. You can see if you know where to look, you can see the planets in the daytime. So right now, Jupiter rises around 4 a.m. and remains in the daytime sky for a number of hours during the middle of the day. And if you knew where to look, you could see Jupiter without binoculars, just as a little bright pinpoint of light. Jupiter and Venus, you can do that with both of those.
That's so cool.
What's great is that every now and again, when the moon passes near them on its journey along the ecliptic path, there are year and the right next to it. So you use the moon as your guide to see the planets.
That's such a cool thing to do. Huh, very neat. Okay, just a reminder to folks as we mentioned that don't look at the sun. Just a big old reminder.
Exactly.
All right. I'm going to end the poll now, and we've got a very clear winner here with Orion taking 55% of the votes. That is very understandable. Orion's pretty cool. Cassiopeia is cool too. Thank you all for, I'm going to share the results so everyone gets to see. And
wow, runaway.
Runaway, like Orion by far, which is great because we're just at the end of Orion season now. So you can still see him up in the sky, which is nice. All righty. Shall we get started? Welcome everybody. Thank you all for joining us a second time. And for those of you who are here for the first time, welcome. And we're going to start with going over the questions that we went through, that we assigned to you guys for homework last time.
Very good.
So I'm gonna read out the questions. If I fall off the face of the earth here at any point, I'll just remind everybody I'm on a rural connection, so I will be back soon. Chris, shall we start with the first one? Are you ready to go?
Let's go.
Alrighty, the first question is, when can you see Mars, Jupiter, and Saturn this week?
All right, so clearly we don't have the ability to see the planets up in the sky. So first of all, let's try, I'm gonna just hit F5 and bring up my TARDIS time and space control here. I'm just gonna set the time later today and let the sun go down and see what we see. So obviously we get Venus popping into view after sunset and Uranus, and the planets are always concentrated in a path across the sky that corresponds to roughly to the plane of our solar system. So our sun is in the middle of our solar system and all the planets orbit around it in more or less the same plane. There's a little bit of tilting from the individual planets here and there off of it. And so if we draw the ecliptic, which is the path the sun takes through the stars, that ecliptic basically defines the plane of the solar system across the sky. And in Stellarium, you can display the ecliptic by hitting the comma key on the keyboard. So I just hit the comma key, and you can see that Uranus and Venus are hanging out near the ecliptic line. And if I swing around a little bit, you can see the moon is near it, but not on it. Now the moon's orbit is tilted by 5 degrees compared to the ecliptic. And that's why as the moon goes around the earth once every month, it sort of rides up and down as it goes around like the horses on a carousel. And so that's why even though the moon passes where the sun is every month, normally the moon is either too high or too low to pass in front of the sun. And it's only on those certain occasions where the moon happens to be around the ecliptic or very near the ecliptic at the same time as it's sharing the sky with the sun, that we get a solar eclipse happening. So if I continue on here along the ecliptic, we can look later. So now I'm looking at 8:30 p.m. tonight. If I go 9:30, 10:30, 11:30, 12:30, sorry, 1:30, 12:30, 1:30, 2:30, still no planets, 3:30, 4:30, boom, there we go. So as a matter of fact, at this current time, Jupiter, Mars, and Saturn are all hanging out together in the southeastern pre-dawn sky. They all rise a little bit after 4 a.m. In your local time zone. And it doesn't matter where you live at mid-northern latitudes or anywhere in the world, really. Those planets should come up around 4 a.m. Anywhere globally in local time. And then they'll be visible. So if I go another hour or so here, let me just zoom back out. 5:30 by 6:30. Jupiter being the brightest planet will persist into the dawn light, the twilight as it grows, and eventually you'll lose dimmer Mars and Saturn. So you should be able to see Saturn, Jupiter, and Mars anytime between about 4:30 a.m. when they get a little higher above the horizon until sunrise, almost sunrise. So that's the answer to number 1. So Mars, Jupiter, and Saturn are hanging out in the pre-dawn morning sky.
I noticed some of you had really, really detailed answers for that, and to you, kudos. The next question is, which planet or planets are hidden by the sun's glare this week?
Well, for that, let's go back to the daytime sky. I can actually just hit now. Bring the sky into the view. And so what you may have gathered is that I can go down here. Remember I showed you the other day that we can actually switch off the horizon or switch off the daylight. So if I switch off the daylight, then I can bring Mercury into view and Uranus into view. And if I just run back, let's say to lunchtime, noontime, then if you're facing south around 12:30 p.m. after lunchtime, then really you've got Venus sharing the sky with the sun, Uranus sharing the sky, Mercury, and then of course Jupiter and Saturn and Mars are setting as a group right around 1 p.m. in the afternoon. So that's the answer to that question.
Perfect. And I guess the ones that we absolutely cannot see at any point would be Mercury and Uranus because they're too close to the sun, eh?
Well, Mercury is enough degrees away from the sun at the moment that if you were living at the equator, then Mercury might still be in a semi-dark sky before sunrise. You could see it, but Mercury is actually in the process of swinging back towards the sun and going to rendezvous with solar conjunction soon. And then it'll join the evening sky in a few weeks. And then we can take a look. Once we preview the upcoming viewing season, we can see when the best dates would be to see Mercury. Okay. Uranus being a dim outer planet, a small, not small planet, but so far away that it's relatively dim. It's not visible. And Neptune, I believe Neptune is, let's see if I can, there's Neptune. Neptune's actually hanging out right next to Mercury right now. And again, Neptune being the farthest classical planet right now, then it's least visible, okay, even at the nighttime.
Yeah, it's a tricky one. You can't see it without a telescope, right? Or binoculars.
You can see it. So Neptune is really one of my favorite planets to look at with my telescope. You don't need a giant telescope to see it as long as you know where it is. And what's cool about it is that it really looks blue. Oh, so it's named Neptune, after the god of the ocean, because it reminded the early astronomers, the discoverers of the ocean, the blue color. And in a telescope, it really looks blue. It's actually spectacular.
Very cool. Tiny. Yeah, I bet. Okie dokie. Next question, which works well with what you've got up right now. What constellation is the sun in at the moment?
All right. So hopefully everybody figured out how to turn off the daylight. They didn't need to, but I've got the daylight turned off. And what I'm going to do is I'm going to reveal the constellations using my constellation lines and labels. And so we can reveal that today the sun is actually sitting right near the constellation of Pisces. And if I just bring on the boundaries here, I don't have the boundaries visible, but I can switch on that option in a couple minutes. Let me just go here. Oops, go down to settings. If anybody wants a few more extra features on their menu, you can go into extras here and you can ask it to show some additional buttons in the background. So we can have the constellation boundary showing, we can show the asterisms and the asterism labels. I'll explain what those are in a minute. And let's put on, I'm going to put on the flip buttons because those are handy to have. And then I'm going to go back to main and I'm going to save my settings. Okay, so now I've got an extra button here that lets me put on the boundaries of the constellations. And I'm just going to make them a little brighter so everybody can see them a little bit better. Okay, and the constellation line's a little bit brighter as well. Here we go. So the sun is actually just inside the border of Pisces right now. And if anybody is a follower of astrology, then you'll know that your so-called star sign was derived from the location of the zodiac constellation the sun was in on the moment of your birth. The tricky part is that that system was generated a couple of thousand of years ago when astrology was being developed as what they called a science in those days. Of course, we don't think of it as a straight pure science nowadays, but there's plenty of astronomical concepts that are sort of embedded into astrology. So if you're your birthday is around this time of the year, you might be a Pisces or an Aquarius or an Aries. It sort of fluctuates a little bit that way. And of course, that brings up the concept of the zodiac. So everybody can see here, we've got Capricornus, Aquarius, Pisces, Aries, and Taurus. And you can see that the ecliptic is touching each of those constellations. And in actual fact, the sun stays on this ecliptic path. So as the Earth revolves around the sun, orbits the sun once every year, the sun appears to change its location compared to the distant stars beyond us, beyond it. And it's a perspective change. And as the Earth moves, every day of every day on Earth represents about 1 finger width of movement of the sun along the ecliptic. So it actually, over the course of many weeks, it tracks along the ecliptic.
Yeah, I guess
so if
because
I were to jump, sorry?
It's about 360 degrees around and we
Yeah.
have 365 days. So yeah, that's
Yeah.
really cool.
Yeah, a finger of sky is about a degree. So it works out to about a finger's width every day. Yeah,
Very
so if
cool.
I jump ahead to May 2nd, then you can see that the sun has jumped from here and now sits in Aries. And so it tracks along month by month. So they're actually, the zodiac came about as a result of realizing the ancient astronomers realizing that the sun only ever visited that special set of constellations. Now, many people know that there are 12 constellations in the zodiac, but what you may not realize is that there are 13 constellations that the sun visits in the course of a year.
We have bad news for the Scorpios out there.
So I'm going to advance ahead here a few months. So here's April, May, June, July, August, September, October, November, December. When I get to December, you can see that the sun is not in Scorpius. It's actually in Ophiuchus. And Ophiuchus is the snake bearer. So it actually in the sky, it resembles a Dalek. So you can see there's a flat bottom and a pointy pyramid shaped top and a tapered body. And then the stars that are sitting right about here look a lot like the disintegrator from the Dalek in real sky.
Wow.
But in actual fact, he represents a person who's holding a snake. The snake's divided into 2 parts. Here's the tail, here's the head. And then he's got 1 foot that comes down and trips the sun. And the sun needs to be around December 14th every year. The sun is crossing so he's the missing 13th constellation of the zodiac. And if your birthday's in December, like mine is, then you're an Ophiuchian. All right, let's hop back to now.
Well, there you go. And that, I think, I remember doing a program about the zodiac with some folks up in Vaughan. And if you look at the number of days that the sun is in each of the constellations, it usually works out to about 20 or 30. And then for poor Scorpius, it's only 7. So it gets the shortest end of the stick. Yeah.
That's right.
Okay.
All right.
Let's hit the next question. That was great. So let's go to Venus. What shape is Venus currently showing through a telescope?
All right. So let's put the sky back to normal here. And we'll just advance the time to let Venus pop out of the daylight. So to find the answer to this one, the best thing to do would be to select Venus as a target, press the space bar to put it in the middle, and then roll your mouse or your paged up and down key to zoom in. And that will reveal that Venus is a half illuminated shape right now. And the reason it's a half illuminated shape is that it's actually rounding the outside curve of its orbit. So if I go in here and set to solar system objects and show the orbit of Venus, I'm just going to wind out. You can see that Venus is almost, but not quite, at the outer edge of its orbit. On the day that it gets there, which will be, it's just past it. So I'll go back a few days. So right around the last week, the end of March, Venus hit the outer edge of its orbit, and it would have been exactly half lit up by the sun, which is down below it. All right, so then we head back into today. And that's Venus. So Venus is looking about like a half I'll say half moon, but that's not right. But a half illuminated phase. So we call the amount of illumination of a planet its illuminated phase, or its phase angle. And its phase angle is actually given in this list of information as being 45.9% in here. And if I advance forward into the future day by day, you'll see that that number down here under illumination changes a little bit. And as we go into the future, and I'm just gonna let the time go later so it's in a darker sky, you can see it's turning into a crescent. And Venus is turning into a crescent and also getting larger. So by the time we get into early May, Venus is much bigger. It's also now a crescent phase. It's only 23% illuminated. And as we go even more and more and more, whoops, I just lost it. Let me come back. Come back a second. And the reason for that is that Venus is actually moving now during the next month or so into the space between the sun and the earth. And as it approaches or starts moving into that space between the sun and the earth, it's getting closer to the earth. And so it's getting larger. And because the sun is farther away than Venus is at that time, then the planet is being illuminated on the far side that we don't see. And so we're seeing less and less of it on our earth facing side illuminated. So it becomes a thin crescent. So that's how Venus looks right now in a telescope. We'll go back to today.
And just
here.
For those at home, there's something you can try both with, I mean, if you want to try it with Venus as a model, you can, or you can use it for the moon. If you have a golf ball or a styrofoam ball, something round, and a bright point light source, like a bare bulb from one of your lamps, you can, first of all, set up a model where you're the Earth and the ball is the moon, and you can have it orbit around you to see how the phases change. Or you can set it up so that it's Venus and Venus is passing on its orbit between us and the sun. And that'll show you that no matter what, 50% of the planet is always lit up. It's just not always the 50% facing us.
Good point. Excellent.
That one sometimes people get confused because they're like, the moon's totally dark. And you're like, no, it's not. It's just pointing the wrong way.
It's only dark on the side we're looking at. So while we're on the topic, Jenna, I think we should talk about what's going to happen with Venus.
Yes.
We talked about this the other day, but just to recap, you can see this gorgeous set of stars just above Venus in this view of the sky tonight. This is Venus in the sky tonight on April 2nd. And if I advance to tomorrow night, you can see that Venus is actually almost one of the stars in this bright star cluster. This star cluster is called the Pleiades, or Messier 45. It's also known as the Seven Sisters from Greek mythology. And in Japan, it's called Subaru. And it's actually this set of brighter stars are actually in the logo of the car company. And
so cool.
Venus's path through the sky is on a regular cycle as it orbits the sun, and the regular schedule of Earth's orbit plus Venus's orbit set it up so that every 8 years, Venus passes through the Pleiades. And so we're getting this rare, semi-rare opportunity on Saturday night to see, or Friday night to see Venus go right through the Pleiades. Now, Venus will be extremely bright. This is not really a representation of how it will look visually. So Venus will be extremely bright, much brighter than the stars in the cluster. So you'll notice that in a telescope, for example, Venus would really overwhelm the view. But certainly in binoculars, you'll be able to see that Venus is accompanied by all these other stars in this cluster.
So I do have
That's a cool thing to get out and look for. Now, if it's cloudy on Friday, you can go out and look tonight. Venus will be just below. So let me pull back a little bit. And then tomorrow, and then the following night, just above. So you've got a couple of nights, although, you know, the really, really important or best one is tomorrow night. So get a picture.
Yeah, I want to throw out something quickly too, because so I'm with the Royal Astronomical Society of Canada, which I can't believe I haven't mentioned yet, and Chris is a volunteer as well. And at the RASC, we have a robotic telescope that's down in California. And on the back of the telescope, so this wouldn't fit in a telescope field of view, but on the back of the telescope, there's a camera. There's a digital camera. And last night, our team took a photo of what they saw. So I'm going to share with you. I'm going to steal your sharing away, Chris. Hope you don't mind. And we'll see if this works. So I may depart as I try to stream this, but I'll just show you quickly. Here's the photo that they took last night. So there's the Pleiades there, and then there's Venus right beside it.
That's amazing.
So they took that remotely just by, I'm going to stop the share before I totally crash out of this whole thing. But they took that just by programming the telescope to point at a certain part of the sky and then telling the digital camera on the back to take a quick shot. So that's similar to what it would look like through binoculars.
Fantastic. Now, just before we move on, I think it'd be, because everybody's got Stellarium and is learning how to use it, I think let's try the experiment of advancing the date 8 years.
Oh yeah, let's do it.
All right, so here's 2020, April 3rd, 2020.
Oh,
let's
can
put
you,
in 2028.
Hold on, Chris. Wait, Chris. Can you share your screen again, please?
Oh,
Because I stole it.
sorry. Let me do
Sorry.
that. Thank you for catching that. All right, yeah. So as I said, I've got my time control, my date and time control here. Let's do an experiment. We're all scientists. Let's set this to 2028 and we'll see what happens. And there it is.
Oh, cool.
On the same date in 8 years, it'll be there. And what's another 8 years after that is 2036. And there it is again.
Oh man.
All right.
That's amazing.
I think that's a cool experiment. All right.
That's a very cool experiment. It proves that it is something that happens every 8 years. Very, very cool. So this is your last chance for the next 8 years to see it in this spot.
That's right.
All righty. Okay, shall we head on to the next question?
Yes.
All right. Okay, so now we're back on constellations. What constellation is setting in the west as the sky gets dark this week?
All right, so we're already, we've already a little bit past daylight. So let's go back an hour or two. And I'm just going to advance the time in real time and continuously. So let's see if I can do flow time continuously here. See if this works. Here we go. So depending on the night sky, the location, you might have made one or two different answers to this question. So we've got a couple of candidates. So the sun's going down, it's getting a little darker. So what's the last constellation that you can really see? So, it's a mix between Aries here and the top of Pisces. Let me just pause. Let's go back a few minutes just to see that again. So this will be Cetus. Let me just bring this back. This is Cetus, the sea monster. This is the head of the sea monster. It actually almost looks like a rubber ducky in its shape. But if we bring this down, so Cetus is setting in the west right at sunset, and Aries is starting to get down there as well. And then over here, we've got Triangulum.
Triangulum.
I'm going to just change my landscape to something a little more open. Let's see, I think Garching would be, Garching really, oh, not Triangulum, that's, let's go back a bit. That's part of Pisces, right? We knew that because we knew Pisces, the sun was in Pisces. So that's the eastern half of Pisces, heading down as the sun goes down.
All righty, well, we can say goodbye to Pisces as it sets, because this will be the last time we see it this season, more or less, eh?
That's right. So we're going to have to wait a number of months before it returns. It'll return first in the morning sky, and then eventually it'll migrate around and become visible in the evening again in about 6 months.
I just have a question that I forgot to ask from someone in the chat, which was what was the toggle again for showing the ecliptic? It was a comma, right?
Pressing the comma key on the keyboard.
Okay. Perfect, thank you. Sorry, I just wanted to throw that in there while I remembered. Okay, are you ready for the next question?
Sure.
Okay, this one's one of my favorite ones. What constellation hosts the object named Messier 42, also known as M42?
And it's everybody's favorite constellation.
Hey, 55% of you.
So M42, we can put in the list here. And say go. And that brings it into the center, and you can already tell it's Orion. And so what we'll do is we'll zoom in on M42, and we can see that it's the Great Orion Nebula, or the Orion Nebula. And what's great about this object is if you love Orion now, you'll love Orion even more once you understand what this is. So this is actually a stellar nursery. It's a patch of space in our Milky Way galaxy, in one of the spiral arms of our galaxy, where a large molecular cloud of hydrogen gas is in the process of collapsing and forming new stars. And what you're seeing when you look at Orion in the night sky, you can see the 3 stars in his belt, no problem at all. And normally on a, if you're not under a very light polluted sky, you can see his sword hanging down from his belt. And if you put your binoculars on the sword, you're basically going to see 3 patches of light, and the binoculars will reveal that the middle patch is fuzzy. And that's because it's actually this nebula. And in a telescope, now a backyard telescope won't show you these brilliant colors, but you will see this image in a black and white form. So you'll see sort of ghostly wisps of gray, whitish and gray gas. And then you might see some dark patches that are dust that are interfering with the glow of the gas beyond them and producing some fantastic patterns. And if you use a telescope and you zoom in on the middle of this nebula, you'll find that there's a little patch of stars. And I think I can turn off, let's see if I can turn off the nebula here. I can't do that right now. That's another setting. Let's see if I can go to the settings and turn that off for us. Some extras. Show nebula background button. So I can turn off the picture of the nebula, and I can see that there's a patch of stars in the middle of the nebula, and these are baby stars. They've been all born from the same cloud of gas, and they're basically a star cluster. And they're called the trapezium because they look in a telescope like a trapezoid shape. And if you have very good conditions and a pretty good telescope, you'll see actually not just 4 stars, but there are actually 6, 2 smaller, dimmer stars in the same vicinity. So that's called the trapezium.
You can see that even through all the brightness of the nebula?
Yeah. No, the nebula is not nearly as bright compared to the stars in the center of it. So let me just bring the nebula here. Now, the Hubble Space Telescope, and this is probably a Hubble picture, has taken very close-up pictures of this nebula and have discovered dozens of what are called proplyds. And those are embryonic solar systems. So those are little clumps of dense material that's swirling in a disk around stars and getting ready at one point to form future solar systems. And so it really helps us understand the formation of our own solar system by studying star formation in these other locations. Now, when you're looking at this object, bear in mind that its distance is 1,343 light years away. So the light has been traveling for more than 1,000 years to reach your eyes or your binoculars or your telescope when you're looking at the Orion Nebula.
That is super cool. I have another question just from someone in the chat.
Sure.
And then I have something that I want to throw out there for people to try if they want to. The first question is, how old are those stars? So when did they originally form?
I've heard different numbers. I'm not sure that anybody knows for certain, but I've heard numbers like 1 million years old or a few 100,000 years old. Probably in the order of 1 million is probably a good guess, though. Very, very young stars, just beginning their life cycle.
Yeah, big little baby stars. Okay, cool. And then the thing I wanted to mention to folks was an activity that I've done with kids before. If you want to see how planets form and you have lots of time and Play-Doh on your hands, you can tear Play-Doh up into little small pieces, like pieces half the size of your pinky nail or about the size of your pinky nail, and put them in a paper plate, and then put your hand on top of them. So spread them out, put your hand on top of them and start making slow counterclockwise circles, and they'll start to clump together. And that's how planets form, generally speaking. It's not a giant hand pushing down on all of the dust, but you get the idea from that.
Yeah. Now, I think, Jenna, one day during one of our sessions, we should talk about Messier, who Messier is and why we call this Messier 42.
Yes.
So, we'll remember to describe. It's really a cool story. So we'll talk about that in a future session.
Maybe we can throw that into the Ask an Astronomer section, because I quite like Messier too.
Sure.
Okay. All right. So if you're curious about Messier and him and why all these things exist and are labeled with M's, you'll join us for the Ask an Astronomer section. And for the next question, I really like this one. Also because it still has to do with our favorite constellation. Which two bright springtime stars have a connection to the Harry Potter series?
Okay. So if anybody has taken a look at Stellarium and zoomed in on Orion, when you zoom a little closer, the star labels become revealed, the primary prominent stars in the constellation. And one of the two names that I was thinking of is this star, which represents Orion's western shoulder or armpit. We're not sure because we know Betelgeuse is translates loosely as the armpit of the hunter, but Bellatrix anyway. Bellatrix is the other western shoulder or armpit star of Orion, and Bellatrix was Bellatrix Lestrange in the Harry Potter series. She was a bad. She wasn't a good person, right? Bad character. Now, I'm going to give you the other name, and then I'm going to give you a bonus on top of that. So, J.K. Rowling took the name of the star as one of the main characters in this series, Sirius. Sirius is the what we call the dog star because Sirius is the brightest star in the constellation of Canis Major, the big dog. Sirius is also known as Alpha Canis Majoris. So we take the star and we start with the brightest star in the constellation. We call it Alpha, and then the second one is Beta, Delta, Gamma, and so on. More or less, there's some rules that are broken here and there. And then we take the Latin name of the constellation and we turn it into a genitive form. So the first star of Canis Major would be Alpha Canis Majoris. So, but everybody likes to use Sirius. So Sirius is Sirius Black from the Harry Potter series. And J.K. Rowling very deliberately chose this name because Sirius Black, the character, had a connection to dogs. And I don't know if I want to spoil this story. But
yeah, I was going to say, I mean, like the books are like really old at this point, but.
yeah. So anybody who's familiar with the character will know what I'm talking about. And if you don't, maybe you'll be compelled to go in and take a look. Now, the last thing, and by the way, Sirius is the brightest star in the night sky. It's only, one of the reasons for that is that it's a hot luminous star, but it's also right in our own backyard. It's only about 9 light years away from us. So that's one of the reasons it's bright. All right, the last bonus, I'm going to swing us around and face us north. And I'm going to point out Ursa Minor here and Draco. So there's Draco, as in Draco Malfoy, as your bonus. Not a star, but a constellation name.
Hadn't even occurred to me. That's a really good one. I noticed, and this is very specific, and I haven't actually read through, don't hate me, anybody. I haven't read through all of the Harry Potter books, but I think it was in the 5th movie, there was a family tree of the Blacks on their wall, and a ton of people were named after stars. I'm pretty sure there was someone with the name Andromeda in there. They don't come up.
There's also a Regulus.
Hey, oh, of course, yeah. Oh man.
Regulus Black. Yeah. So here's another thing you can do when you're sort of learning how to use Stellarium is you could go to the character names and type it into the search and see if there's an astronomical constellation or some other connection to the books that J.K. Rowling used.
That's very cool. I just had a question from someone in the comments and I realized I don't know how to, or in the chat, and I don't know how to answer it, which is there a resource to help use iPad or iPhone Stellarium? Because they don't have, I guess they don't have a toolbar. So we're not planning on covering that because I don't know. I don't know if you have an iPad, Chris. I don't. So I can't cover it.
I can cover it at some point. It does take a little bit of a different approach to get it to work, but there is help around.
Okay, I'll take a look.
We can see about. We'll talk about apps at some point, and I'll show people briefly how to run it. That way. Yeah.
And since we were talking about Orion, there was another question in the Q&A, which is where's the Horsehead Nebula in Orion?
Good question. So the Horsehead Nebula is actually tucked right up against the eastern or left-hand star of Orion's belt. That star's name is Alnitak. And if you zoom in with stellarium on Alnitak, you can see that the Horsehead Nebula is sitting to the lower left. Now that's a very, very dim object. So it's not something that you're going to see in a backyard telescope or even a big telescope. But you might be able to pick it up if you take a long exposure photograph by attaching your camera to your telescope. The cause of the Horsehead Nebula is that there's a gas, there's a cloud of hydrogen that's distributed across this patch of the sky. And when you energize hydrogen gas with radiation, it glows with a red color. And then the horse's head aspect is actually black dust that's sitting between us and that glowing red gas. And it just happens to make the silhouette of a horse's head or maybe even a seahorse shape.
Actually, yeah, it really does look like a seahorse, doesn't it?
Yeah, that's the horse's head. Now, to the upper left of Alnitak is another glowing nebula cloud, and it's actually got a distinctive shape. We call this the flame nebula because it almost looks like an inverted color, an inverted photo of a flame, where the fire is black and the heat is white. And you can see that we've got some sort of a blue halo around some of these stars that are nearby. And when you bounce starlight off interstellar dust, it scatters favorably with blue light. And it's the same reason we get blue skies in the daytime on Earth, because the sun's light is scattering off the atoms and molecules in our atmosphere and giving blue light, sending blue light to our eyes. And so these blue halos that you're seeing around the stars, those are indicators that there's interstellar dust surrounding those stars.
Very cool.
Yeah.
Excellent. There was one more question just in the chat, and this one's a relatively easy one to answer, or sorry, in the Q&A, which is, you referenced Bellatrix as the Western star, and someone mentioned that it's visible in the east. Why is it called the Western star of this constellation? Yeah,
so the stars can actually, the constellations of the stars can sit pretty well anywhere in the sky, because as the Earth rotates, they move from side to side. So if I run the hours back, let me just sort of send this on south. So let me start by this. So if I go back a few hours, Orion starts by rising in the eastern half of the sky. During the course of the day, it crosses the sky because the Earth is rotating. And then by the time the Earth is rotated away from the sun, where we are, then you find Orion sitting in the western half of the sky. So that puts it, that's sort of that perspective, that things can be in the east or the west, depending on their relationship with the time of the day and the way the Earth is pointing. But in terms of whether a star is east or west in a constellation, that has to do with Polaris. So let's just bring this back a little bit. And the other day I showed this equatorial grid. Let me get rid of the constellation boundaries. So right now I've tilted the sky so that Polaris is at the top and the southern celestial pole is at the bottom. And so in this sort of coordinate system, north is up, so up towards the Little Dipper, south is down, and then west is towards where the sun went down, and east is towards where the sun goes up. So from this point of view, Bellatrix is towards the west side and Betelgeuse is on the east side. And that means that Bellatrix will always rise before Betelgeuse, because objects move from east to west. So the ones that rise first are west of the ones that rise second. Hope that's relatively clear. We can elaborate on a future session if somebody's still not clear on that.
I think that was pretty good. That one, it is tricky to visualize this stuff, but the big thing I tell folks is, certainly when figuring out which way west and east is when you're facing south, they're backwards from what you think they are. So instead of it being in a circle going north, east, southwest, going clockwise, and east looks like that, it's going to be on your right hand side, but since you're facing south, it's backwards.
Yeah.
Which is why we see the sunset in the right if you're facing south.
That's
and
right.
maybe I'm the only one who thinks that we should all face south when we're observing, because I'm used to Toronto and having its lake to the south.
Well, on one of our sessions, see if we have time, we can do a really fun thing and pretend that we take a virtual trip to the Southern Hemisphere and sort of see how the sky's different down there.
Yeah, that sounds
using
great.
Stellarium. Yeah, we'll do that.
Okay. Next question. We still have 4 more to go and we only have 15 minutes. We have really been delving into these. The next question is, which constellation represents a unicorn and where is it located?
All right. So did people know?
I want to know. Does anyone, can folks tell us in the name of the constellation in the chat? Anybody know? There. Phil knows. Phil's got an unnecessary advantage. This is an unreasonable advantage, Phil. You're not allowed to answer.
Let's break it down. Let's break it down. So there's an animal in the there's an animal that we find in the wild called the rhinoceros, and the rhinoceros is actually a Greek or Latin name that means horn for a nose. Because rhino is nose and ceros is horn, and so unicorn would be one or monoceros. So you can see it's right there. Monoceros is one horn. That's the unicorn. And it's not a very bright constellation, but it's sitting here right beside Orion. It's always just sitting to the east of Orion, and it's sitting between Canis Major, so right above Sirius. If you see some sort of modest stars, that's the unicorn.
Perfect. And there's a hint at a question. Oh wait, no, it's the next question that's coming up. About the winter hexagon, because it's kind of smack dab in the middle of the winter hexagon, isn't it?
Yeah, it's sort of dipping its nose into the winter hexagon. Yeah.
Okay. So we'll move on since that's a nice little transition there. Which bright stars form the winter hexagon?
All right. So the winter hexagon is past its prime for this year, but we're still able to see it. So let's just wind the time back a little bit here. The winter hexagon is what we call an asterism. So there are actually 88 official constellations according to the International Astronomical Union. And the sky is divided up into a zone or a section for each of those 88 constellations. So if I draw the boundaries that I indicated before. So watching the sky is actually on the border of or inside one of the constellation boundaries. Now, an asterism is actually a pattern. So just as a constellation is a picture made out of connecting the dots of the stars, an asterism is the same thing, but an asterisms are unofficial. For example, the Big Dipper is an asterism, not a constellation. And we'll look at the Big Dipper another time. But I want to talk about this asterism called the winter hexagon or the winter football. And it's made up of the bright stars in the winter sky, starting with Sirius, Rigel, Aldebaran, Capella, Pollux and Castor, Procyon, and back. And you can see I traced out a big oval in the sky. And if you've got buttons enabled for the asterisms that I went and did at the beginning of the session in the setup menu, I can draw that box in the sky. So I got more than one asterism plotted on here, but you can see that if I make an imaginary line starting at Sirius, go to Rigel, Aldebaran, Capella, Pollux, Procyon, Sirius, there's a big hexagon shape, and that's visible starting in the fall, and then we've got another number of weeks, and then it'll be gone for the season. And some people like to actually go to Rigel, come up to Aldebaran, and go in to Betelgeuse and make a big G. So that's another way of doing it. So you're actually at liberty to make up your own asterisms and invent whatever you see in the sky.
I like that. I every once in a while, kids come to me and they say, well, I saw the vacuum cleaner. And it's like, great. That sounds amazing. That sounds like the best asterism there is out there. I love it.
Yeah. My favorite's the teapot.
Oh, I love the teapot too. That's a summertime one.
We might make that a mission question. So we won't say any more about it right now.
Okay. Super secret mission question for later.
All right.
Second last question now. On April evenings, will the Big Dipper hold water or spill it?
All right, so the Big Dipper, let's just wind back and find out where the Big Dipper is. So the Big Dipper is what we call a circumpolar constellation. So circumpolar constellations are the ones that never drop below the horizon where you live. And so Ursa Major being in the same vicinity as the Big Dipper being sort of near to Polaris, then it's never sets for us in mid-northern latitudes. So here we are looking north I'm just set this back to 9 o'clock, just so it's not too late. So if people want to go outside, it's still almost starting to get dark by about 8:30. So we can set it to about 8:30. We'll start seeing the stars of the Big Dipper. So you can head outside as your homework, face roughly north or northeast at about 8:30 or 9 o'clock. And you'll notice that the Big Dipper, which is here, is upside down. So it's spilling its liquid, and it would be caught by the Little Dipper. So that's the answer. So on April evenings, the Big Dipper will not hold water, it'll spill it. And the reason that I mention April is because every month, the Big Dipper rotates around. Let me just put the sky up to, say, around midnight. So here's where the Big Dipper would be close to midnight in April, and at the same time in May, in June, in July, in August. So each month, the Big Dipper moves its location at the same time of the evening. And so some cultures, and say in China, they look at the orientation of the Big Dipper and they decide which season is commencing based on the orientation of the Dipper.
Mm-hmm. There's a neat story in, I believe, Haudenosaunee culture that that talks about the three stars in the Big Dipper's quote tail, and sorry, in Ursa Major's tail. But in their culture, those stars are hunters, and they're chasing the Big Dipper around the sky.
Yeah, we'll do an Indigenous astronomy session, and we'll talk about that story.
Yeah. And I think we're down to our last question, for at least for the quiz, and then I have a couple questions coming to ask you from the Q&A. So this last question is, what kind of creature is the constellation Camelopardalis? I don't know if I pronounced that right.
So again, by clever means, I've segued into the last question, and I actually have the constellation in view in the northern sky. There's Camelopardalis. You can say it, there's different ways of saying it. But I think if I say it Camelopardalis, it might be a little more clear of what's going on here. So this is actually two animals' names put together. Camel, leopard. So what's unique about a camel? A camel is sort of a long-legged animal with a long neck. And what's unique about a leopard? A leopard is a cat that has spots. So what's a long-legged, long-necked animal with spots?
Oh my goodness. Sorry, I never knew this. This is really exciting for me. Anyone got the answer in the comments?
Revealing. Giraffe. So Camelopardalis is the giraffe.
Wow, I can't believe I never knew that. Wow, thank you, Chris.
And again, it's a modest constellation. The stars aren't very bright, but it actually sits up there in the sky between Mercury, which is a bright star in Perseus, and Capella, which is a bright yellowish star in Capella, and Polaris. So if you can sort of find those stars and that patch of sky that will probably look empty from the suburbs, it might start filling with stars when you get out to the country. But that's the giraffe. It's a mild, sort of gentle animal, and it's sort of a mild, gentle constellation.
Oh, isn't that lovely?
All right.
All right, we've
got a bit of time. Yeah, we've got a bit of time for some more questions.
Is there anything else you wanted to cover in this particular session, or do you want to jump into some of the questions that we have?
I think we could jump to questions. Oh, okay. Yeah, let me do one more thing before we leave. I want to make sure everybody knows how to put up their measuring the sky tool.
Oh, good idea.
So what you do to get a tool to help you measure the sky is, if you go to the configuration window, navigate over to where it says plugins, and then look for this. This is actually a list that you can scroll through, but you want to find the one that says angle measure. And you want to go down and you want to put a check mark beside this that's loaded at the startup. And then head on over to main. And I'm just going to turn off my constellation lines and stuff so I don't save these, but I'm just going to go here and say save the settings. And then the next time you launch Stellarium, so I'm just going to shut down Stellarium and relaunch it, and then I'll have that tool waiting for me. So let me just do this. So it doesn't come in until the next time you start it.
This is especially useful because you can't use your hands to measure Stellarium, unfortunately, because you can scroll in Stellarium.
There we go. So let me just put this into the nighttime sky. And now down here, I'll just put on the constellation lines again. So now I have a tool in here that looks like a compass. It's got a V with an angle in the middle of it. And if I click that on, then I can point at the sky and I can click and I can drag and measure a distance. So you can see how the farther away I get with that, the more degrees and minutes and seconds it is. So if you want to know how far away in the sky is Sirius from Orion's belt, it's 21, almost 22 degrees. That would be represented by about 2 outstretched fist diameters.
Okay.
Yeah.
Perfect.
Yeah. And when you're done, you just click it again and it puts it away.
Perfect. I'm just going to answer a quick question in the comments, and for you, Chris, I'm going to ask you. This was answered actually by one of our Ask members, Blake, but I'll get the answer out for everyone, which is, why is it preferable to view Venus overlaying Pleiades with binoculars instead of a telescope?
Thanks, Blake. Yeah, so let me just bring this guy back here. There we go. You're asking the question at a perfect time, because most binoculars will cover an area of sky that's about 6 degrees wide. So that would be something like that. So you can see that Venus and the Pleiades would nicely fit inside that sort of 6 degree field of view. Imagine a circle about that big across the sky. But a telescope's field of view is much narrower. A telescope's field of view might be only maybe about 1 degree, or maybe if depending on your telescope, 1.5 degrees. So you can see that the Pleiades would sort of fit in, but they'd be spilling out of the edge of the field of view. Mm-hmm. So the binocular will give you a nice all at once view, and the telescope, you might only see sort of a section of it at a time.
Okie dokie. There we go. Sounds great. Okay. Okay, hold on. There's a couple of more advanced questions. The one question that's coming up, and I think we mentioned this last time, some folks were talking about Comet Atlas, which is this new comet that's brightening in our sky. And someone wants to know where you can look. Just a heads up, if you get a newer version or an update to Stellarium, it'll be in there. But Chris, I think your version doesn't have it in there. Is that right?
I don't think I went ahead and installed it yet, but I will do that for next Tuesday.
Okay.
This is not the best week to go looking because the moon is becoming full. So the Comet Atlas is expected to brighten. It's predicted to brighten. We can't guarantee it will, but we're hoping by a month from now that it'll become bright enough to see in binoculars and maybe even with the unaided eye. But during this period, it's still quite dim. And with the bright, nearly full moon in the sky, the moon's going to be full, I believe, on Monday. So let me just put the moon into view here. Here's the moon. So here's the view of the moon tonight. And then Friday, Saturday, Sunday, Monday, the moon's going to be pretty much full. So that's going to wash away really much chance of seeing a dim object like a comet. But where the comet is located is up near here, right above here, sort of at the top, off the top of the Big Dipper, near Camelopardalis and near the rest of Ursa Major. That's the part of the sky where the Comet Atlas is hanging out these days. So we'll actually, I'll download the minor small bodies database into Stellarium, and I'll be able to show you its path next time we get together.
Excellent. Sounds good. Alrighty. A couple other questions about the moon and some of the constellation names. These are relatively quick. And I can actually even answer one of them, which is, why is there a constellation called Cancer? And that's because it's a crab, right? And that's the name for crab.
Yeah. The crab was around before the disease.
Well, there we go. So how dare they name such a horrible thing after some poor little innocent crab? Hardly seems fair. And then Peter had a question about checking the version number of Stellarium that you're using. Is there a way to do that while you're in Stellarium?
Yeah, you can go down to the question mark and it'll show you about and it'll show you
Perfect.
019.3. And I understand that since we had our session on Tuesday, that they've launched version 20, 0.20.
Oh, wow.
But it's not going to be different. It's not going to be very different. You're certainly welcome to go and grab that if you want to. You don't have to uninstall what you've already done. You can just simply run the install, and it should just overwrite the new material onto the settings you've currently got.
Perfect. And Maury mentioned that that new one has Atlas, the Comet Atlas in there. So if you want to see it, it should be in there.
Yeah. It's also got some new star lore, including an ancient star atlas that I want to highlight in a future session too.
Okay, sounds good. And then another quick question from Maury in Montreal. Can you review how to plot the trajectory of a path, or the trajectory path of an object? I'm not even sure how to do that.
Well, okay, there's two questions in there. There's the orbit of an object, and then there's its path through the sky. There is a way in Stellarium to have it draw the path as it crosses the sky, but I'm going to show you, I've shown you already how to draw the orbit of an object. So you can go to solar system and click on the orbit, enable the orbit button. There's also an option for the trails. So let's see if I can pick an object and see if I can get its trail. I don't work with this very much, so let's see if I can get this to work.
And no worries if you can't.
Yeah.
Oh,
so
cool.
if you click on the trail, so the object that you select. Now you can do it only for the latest selected objects. So if you select, say, the moon, enable this, and then you don't need to leave this box open. Then as you advance day by day by day, you can follow its track across the sky.
Cool.
So we can do that for the comet once we get the comet in the database.
Okay, we'll do that next time. And then a last one from Donna in the chat. She said that last time you mentioned that you would let us know the site that shows you what your viewing would be today, and for evenings coming up in a certain location. I think that must have been a time that my headphones cut out, because I missed that one. I guess, are we thinking like clear sky clocks maybe?
Well, if you're talking about what's happening in the sky lately, what's coming up, then one way you can do that is you can use my Skylights blog if you want to do it week by week. So if you go to my website, AstroGeo, and click on Skylights, then you'll find this week's write-up is this one for March 29th. So you can head into here, and this will be, I'll be writing a new one this coming Sunday for the coming week, the upcoming week. But this will talk about the celestial events that are coming up for this coming week. So if that, I'm not sure if that answers the question, but that's certainly one option for you.
It sounds like it answered her question based on what she just responded. So perfect. And I think that's more or less, I mean, we're at 4:30. So to me, it seems like a good place to stop. Let me check the Q&A for any last little bits. There's a few questions, more technical questions about setting up field of views and stuff like that. And I believe Blake has answered many of those. Thank you, Blake.
Thanks, Blake.
In the comment, in the chat. So I appreciate that. And the last thing that I wanted to do, personally, Chris, do you have anything else that you wanted to add?
No, I'm just going to sort of summarize or preview what we might do next week.
Okay, I'll quickly mention that for those of you who are joining this session, I've got your email addresses through the registration, and I'm going to do a draw to give away one of our observers handbooks at the RASC. So those observers handbooks tell you everything that's going to be up in the sky for the entire year. And so I will be doing that and announcing the winner of that on Tuesday next week.
Fantastic.
And now on to Tuesday next week's class.
So we were thinking originally that next Tuesday we would talk about the year of Mars and expanding on that, kind of the upcoming summer stargazing season. So some of the highlights to watch for, and maybe reasons to dust off the old telescope and things like that. Then we'll probably allow a bit more time for Q&A, and I'll show you a few stellar tricks, and we'll come up with another set of questions for you to hunt down the answers to. Sound good?
Sounds good to me. So that means that you guys don't have any homework over the weekend. Take the weekend, regenerate, take some time to yourself, go outside tomorrow night and look for Venus in the Pleiades.
Well, look tonight if it's
yes,
clear.
yes.
Start tonight, look tonight, look again tomorrow. The looks are free. Check out the Orion Nebula. It's there.
Yeah, take a look at the Orion Nebula, and if you have a pair of binoculars, just do a little exploring around the skies and see what you can find. Let us know what you can find in the next session, and we hope to hear your discoveries on Tuesday. All righty. Thanks, everybody, for joining.
Thanks, everybody.
And we will see you all on Tuesday next week. Have a wonderful weekend, everybody.
Bye.
Bye-bye.